everyone. In this tutorial, we are discussing about convolution neural network, and we will learn some CNN operations. So basically, what is CNN? Convolution neural network defines CNN, and it is the extended version of ANN, which is predominantly used to extract the feature from the grid-like matrix dataset. For example, visual datasets like images or videos, where data patterns play an extensive role. And now we see the we will learn the CNN architecture part. Basically, CNN consists of multiple layers like input layer, convolution layer, pooling layer, and fully connected layers. The convolution layer applies filters to the input image to extract features. The pooling layer downsamples the image to reduce the computation, and the fully connected layer makes a final prediction. So the network learns the optimal filters through backpropagation and the gradient descent. And in this part, we basically download an image from Google, and we basically convert it into four parts, like the original grayscale, the original image to grayscale image, and the convolution, activation, and pooling part. So let's see what the code, each line of the code. So the first line here, we basically import the necessary libraries, like every iteration part or every operation part we do. We import the NumPy, TensorFlow, Matplotlib, PyPlot, and iter2product. And after that, we basically setting up the plots. This line basically configure the plot styles for better presentation. And after that, we basically defining the kernel. This basically creates a 3x3 filter of kernel using TensorFlow constants, and the kernel values define how the filter will operate on the image data. And after the part, we loading and preprocessing the image. So here we get the read file, and basically we download from Google, and after that we decode the image as grayscale, basically one channel, and resize the image to fixed size, so 300 cross 300 pixel, and after that we convert the image data type to float 32 for calculation, and expands the dimension of the image by adding a new axis, the batch dimension, what is called, and reshapes the kernel for compatibility with the convolution operation, and casts the kernel to float 32 data type. And after that convolution part, it basically defines a function. We basically define a function float, that convolution function for the 2D convolution operation using tf.nn and convolution 2D. And after that, this part, and after that we basically applies the convolution filter to the input image with stride of 1 pixel movement per affection of the filter, and send padding to maintaining the image dimensions, and stores the convol feature maps in image filter. And after that, we basically visualize our reducted image, what we call, and it basically creates a figure with 3 subplots for visualization. And after that, we plot the original grayscale image in the first subplot, applies the ReLU activation function here to the convol features, creating image detect, and this introduces non-linearity and plots the image after the activation layer in the second subplot. And after that, we applies max pooling to reduce the dimensionality of the feature maps, pooling window of 2 pixels, and stride of 2, and same padding to maintain image dimensions as we saw before, and plots the pooled image in the third subplot. So basically, in the summary, what we do here basically loads and preprocesses an image, applies the convolution filter to extract features, introduces non-linearity using an activation function, reduces image dimensionality using pooling, and after that visualizes the results at step. So this is it, guys. Thank you.